Sorry, let me repeat because I forgot to open the recording. The first one is the parametric model, and as you can see, the two parts are wholly parametric. What you have to estimate here is the beta and the variance of the error term. And the second model is called semi-parametric model. What is semi-parametric? So it's a mixture of parametric and non-parametric, right? The parametric part is this linear combination, and you have to estimate the beta. But for the error terms epsilon, we don't know the exact distribution of the error term. We only know they are independent with the covariance. And we don't know the distribution of the error term. But in practice, you can still use the OLS to estimate the beta. So the beta hat by OLS is still consistent. But in the parametric model, easily we can estimate this sigma, but it's not the case in this semi-parametric model. So for the variance estimator, you have to make a bit changes in this semi-parametric model. And the last one is called non-parametric model. So fully in this linear regression, we don't know we don't have a linear term of the covariance. We only know the y is a known function of the covariance plus an error term, and both this function and error terms are unknown. So that means we have to estimate function g and also estimate the variance of the error term. But the good thing is, if you have many covariates, the function g, this unknown function, can be approximated if it has some like regular conditions. For example, if you assume the function g is smooth enough, then you can use like polynomials to approximate this function, or you can use spline, many basis functions. You can choose, as long as this function g is smooth enough. And then the second part is decision trees and the random forest. I don't want to go too deep in this part. I think the one thing you have to remember is the difference between the random forest and the Bayesian. Do you still remember what's the difference between the two? The only difference is when you build a decision tree, you have to split it, right? So each split, if you randomly choose a subset of 4 covariates, it's called random forest. If you use the whole number of covariates in each split, it's called Bayesian. And I will show you in the lab session in the code how to distinguish the random forest and the Bayesian. Okay. The last part is the neural network. I think I'll just skip the neural network because we won't use the neural network in the lab session. Yeah, I think it's all. Do you have any specific questions related to the chapter 4 or chapter 3? No? Great. Now we can open the tutorial. I think it's tutorial 3. So have a look at the first exercise in the tutorial 3. So I think we mentioned this data set in chapter 3, right? The eminent domain. If the eminent domain, the rule decision of the eminent domain will affect the house price. So it's what we want to study in this data set. So basically, the outcome is the house price, and in this data set, it's a house price index, but with a log transformation. and the outcome is the decisions on the eminent domain, but it's the number of the decisions which strike down the eminent domain. This is our treatment covariance, yes. And we have some several controls which are related to the local economic condition. Yeah, I'll give you half an hour to finish this exercise. I'll just show you. If you don't know where to get the dataset, you can follow the instruction on the screen. So the dataset is called eminent domain, and the data is by take the logarithm of the somehow price index. So this is the data. And in the dataset, it's already specified what is Y outcome, what is C, what is X, what is Z.
check in the instrument level. Normally you can just calculate if there's any correlation. But now there's so many instruments. Would you do that?
You can calculate each three instrument
Yeah,
is one.
yeah, but then also a lot of
The moment it, I mean, the general idea of instrument to work out ratios.
I know, but
Yeah.
normally you can just for
Yeah.
relevance just calculate correlation.
I mean, you can do one of
Yeah. Okay, I'm not gonna do that, but it's
that. I mean,
that's what you is that what you would do, Shiva?
yeah, if you want really large,
Yeah.
normally it's kind of like a concept thing.
Yeah, I see. Okay. Ook al altijd nog heel lang nadenken. No. What way? Jongen kunnen ook het. Net het moet doen. Het is niet stammen die was. Ja, dat kan mij gewoon zo met. Gewoon helemaal iets. Substrate uit balans wat je doe voor de plannen. Ja, want het is vreemd om buiten de wereld te brengen in een maatje stuk. Hoe zelfs, staat in het podium. Dat niet meer doen. En dan heb ik toch wel een specifieke. Dus heb je zelfs Netflix op je en we zullen gewoon dan willen we zien. Maar zal dat zijn. Dat is heel worden dus. Goeie. Ja, hoe dat lijkt niks. Je doet een. Is ook. Dat ben ik het.
You don't have X.
Yeah, yeah, but
You can say X is now set.
in the question, you don't need to have the X, right? So I try to just leave it out, but then.
You say X. We should say two ways x equals to when you say answer to this one.
Yeah, the
So this is from the C here. It means it's empty. Yeah, because it's empty. And everyone. This is
Yeah.
right. Another way is to say this x is the intercept. So it's a replication of one.
Can you just say intercept?
No, rep. One to the eight.
Yes, it's
One. And with the number is n. So you have to define the n is a sample size. So the rep one n means you have
just the one.
no is a comma.
N.
And you say intercept is false. You say this is intercept that you don't need any values. Yeah. You can the n. Or you don't define what is it. You have to define what is it. Yeah, here before. So the n is equal the dimension d x and it's the row dimension. So you say it's
First.
yeah, this. Yes.
Okay.
Thinking we have a it's something that the default choice is with intercept. So if you don't see anything in the intercept, the default is true. So you will set x as an empty set.
Okay, perfect. Ja, de hulp. De vraag was het is zo'n reference dat is heel dus wat wil het is en dan maakten er wat en dan ineens bij eentjes en dan ja vaak allemaal elkaar gewoon niet besefjes niet van elkaar dan past het maar ja zo kick want ja nou wacht even maar kun je dat erin ja maar ik weet niet of ik dan heb ik dat zo doen. Dan denk ik dat misschien met een derde is, maar ja, dus allemaal tussen overal mee. instruments. Al heel eerste twee doen. En dan heel spelen we dat je dan iets. Tot je moet weer gaan. Oh, really like the boat. There's no tutorial on this one. That's right. Oh, your al die professionele ondernemers maak je veel. 0,1. Min 0,1. Wat zie je het eerste? Gewoon de oorlog. Ja. Oké, dat wordt wel eens. Ja. Ik denk het goed. Zo is het dan wel beter. Ja. Dan ook nog niet veel. Ja. En dan nu min 0,1. Ja. Dank je. Wie en ja. Those three and they those three are what does the exercise do? Perfectly, then zoals this. Dus dat is gewoon een nou, dat wil je dan met dit. Dat wil je dan met dit. Ja, exact. Ik voelde dat wel meer eens. Nee, ook zoiets van voor best. Zie je bij ja, kan je niet meer. Ja, is niet zo. Ja. We staan nog niet zo belangrijk uit school. Gewoon nooit. Je wordt dus gewoon kinderschap. Ik ben dat weet. In een paar studenten staan. Ja. Pakken dat sowieso aan. En gelijk van. Wow. In de zin dat ik stoppen. Ik kan het niet zeggen. Want dat je uw instrumenten selecteert op basis van Nee, soms inderdaad wel was zo dat hij nog steeds ja, ik wil zetten dan heel veel van je story van zo en dan aan zo notities hebben. Wat je wil van een nog en dan ook dus dan leuk. Maar dat is ook nice, dat is ook een fonds waarbij dan plots zoveel wordt een D en E genoemd.
Mhm.
Dus XDE in plaats van XLD. Maar lekker.
Waarom vind je dat?
Niet. Vraag het niet.
Maar je hebt gewoon is een altijd van.
Ja, dan moet je gewoon in plaats van X studeren tot daar wat kunnen. Nee, ik denk dat je gewoon corresponding met een intercept bedoelt. Dat je gewoon dat je een intercept gebruikt als controle variabele. Dus dat je gewoon één doet. Dat is gewoon één. Dus dat is toen dat je dat net in je rep. Maar er is nog een aan 183 zetten. Dubbel. Ja, kut man. Wat betekent dit? Hoe dan? Ja, maar dat is zo'n ding hoor, dat een, ik weet niet waarom het is. Maar ik denk wel dat zo is dat de intercept van natuurlijk een instrument is. Maar dan, het is bij jou een keer gezegd. Dat is heel schön. En dan een onderweg. Dat wordt lang. Hopla. On the X is mean Robinson. X should not be a constant. Zo natuurlijk. Dus jullie kan wel. Ja, welk is wel onmogelijk seconden. Ja, wat is wel. Dat ik dat zit ik aan de kant van de dat er zo'n structuur op en daar ja, wel, ja, het is dat is precies hetzelfde als een lijst, maar je dat van niet zelf kan interpreteren. Ja. Heeft, hoe betreft mijn 0,10, maar ja, er wordt daar wel aan. Ik ben ook niet bij de postman, ik zit hier in de. Ik moet nog wel wel. Die mensen. Ook van mijn nummer. Ja, iets weer. Ja. Ja, ik denk wel als dit routine is, dan is het met de koekers zitten. Ja, want wacht, we hebben nu. Dit is toch al waarschijnlijk niemand zo anders dan zoals je. Maar inderdaad, in deze is. Weet je, als je nu zit, is dat het automatisch? Automatisch, ja. Hier, maar eigenlijk wat dat is hier, is maar wat. Zo eigenlijk wel een keer een post op vals moeten. En zo dan meteen nog een keer een post als zo. Dat is het einde. Ja, ben ik wel bewust van van post op. Maar het ding is, ik doe dat helemaal op het einde en dat is blijkbaar iets anders dan wat je dan in het midden doet. Wat je moet doen. Gewoon een keer kijken in de documentation van die package. Ik heb dit. Ja, natuurlijk, dat komt weer dan ook even snappen. Oké, op naar het bos. Dat is niet zo sapperig, ja, moet gewoon zeggen, maar in het Nederlands, we willen keurig weten. Dat is triest, hè? Maar dan vraag ik me altijd af, voor Amerikanen en dat, ja, ook zo. Hoe is dat dan? Ja, maar dat is echt, dat is gewoon, hoe klinkt dat voor hen? De muziek van de mist, ja. Dat is erg ook was niet, dat moest ik zo herkennen. Nieuwe package zeker. Cool. No documentation, very nice. Maar misschien moet je naar het gaan. Ja, ik heb dit. Zeg maar, snel komen rijden naar hier. Oké, goed. James et al. Ja, maar het zal waarschijnlijk een bepaalde package zitten die dan doen bij. Ja, 18.3.2 van James. No, вообще не Ah, uma quietinha, né? Só mais aqui falando. E老师也是懂了，amanhã e lá esses falar minha frente, quando as pessoas vê elas não é mesmo isso. Gema mostrou muito isso. Mostrou na minha das pessoas da cidade. Start packages. Oh, not found. Sure. See? What's wrong like that? So the left is again. Fasciniano. Claro.
We finished the first exercise. I hope you are okay with the first exercise. We can have a look at the first exercise together. So the exercise 1 is to study, the decisions of eminent domain, the effect of this guy to the house price. And we use this data set from the HDM package. And each observation in the data set corresponding to a specific state in a specific year. So in the data set, it could be a single state but with several years observation. And the first one is to load the data set and specify the outcome and the treatment variable. So I think in the final exam we will directly give you this code like this. So you can directly use Y, use X, use C, use Z. Okay, I think it will be easier for you, right? So you don't have to worry about the first question. And yeah, what's the number of observations, controls, and instruments? The idea of this question is to see if we have high dimensional covariates or if we have high dimensional instrument variables. Let's have a look. What's the dimension of controls? So this guy, the dimension X will return you. X is a matrix, so the dimension of X will give you the number of the rows. So the first argument is the number of the rows. So in these data sets, it means the sample size. So the sample size is 183. And the second argument gives you the number of the columns. So that means the number of the controls in the X. You can always say the first argument is this guy, the second argument is this guy. So we have 72 controls in the data set, right? Compared with the sample size, it's larger than half of the sample size. So we can say it's somehow high dimensional controls, right? And then we can see what's the dimension of IV. It's even larger. So it's 149 instrument variables. It's quite large, right? So we can't run the simple OLS or the simple two-stage least square. We have to use lasso to select a few of these controls or a few of these instrument variables, right? So that's the idea of this exercise. And then we can move on to the second question. So do you think the judge's characteristics are a good instrument variable? Before that, in the data set, the judges are randomly assigned to the courts. So it's kind of like a random experiment. So the first condition of the instrument variable, that is the exogenous, that is the IV should be exogenous, but since it's kind of like a random experiment, so we can expect the IV is exogenous, right? And the second condition is relevant condition. So does the IV affect their decisions? The judge's characteristics affect their decisions. I mean, I can see it's true, right? Because I mean, it's a human nature. Okay. And the last condition is exclusion. So that means the IV can affect the outcome, but only through the treatment variable. So in this case, that is, the judge's characteristics can affect the house price, but only through the decisions on the eminent domain. Do you think say it's true for these for these exclusion condition? Do you think it's true? The judge's characteristics can affect the house price, but only through the decision on the specific cases. I mean, it's not completely true, right? Because I mean, as a judge, you can decide many cases, not only for the cases of the eminent domain. You can decide the cases maybe on the environment, maybe on the some policy, which are related to the house price. So for the last condition, I mean, it's debatable. Do you have any specific? Okay.
Maybe there are rule of other things, but those have a very small effect. Or we can argue that yes, there may be other rulings that they're doing, but they're very small. That we don't consider that significantly.
Maybe for the last condition. Yeah, I mean, yeah, you have. I mean, you can always have your own explanation. Yeah, I mean, there is no once again no correct answer for the explanation for the IV. As long as you think it's reasonable, we will give you the credit. Any other questions on IV? But I want to emphasize again, this is very important. This IV explanation, there must be one question in the final exam. Okay?
In this case, could the judge come from another state?
I think could be.
Because then you could argue that in general they don't rule on cases in that state, and thus it's the exclusion is okay.
Exclusion.
If they mostly rule in their usual states and not in the state where they rule on eminent domain, then they would have prices in that state where they rule on.
Yeah, it's a good point. But I mean, for the eminent domain, if you, assign these, let's say the Pennsylvania state, the judges from the Pennsylvania state, if you assign these judge to another state, especially for the eminent domain, why? For other cases, why not? Assign these judge.
Because it's maybe not all the time.
Yeah.
Listen to
Yeah, I think I don't know exactly if the judge is from the local state. I think could be from different state. I don't know. I'm not quite sure about the American things. Yeah, but it's a good argument. Yeah. Another thing is, if you can go to other states for this case, why not for other cases, right? Yeah. Any other questions? Okay. The next exercise to compare the OLS, double selection, double machine learning, two-stage least square, and some double machine learning with IV. So we can go through from the basic linear regression. So we only regress the outcome on the treatment. including the intercept, right? And this function will automatically include the intercept. If you don't want include the intercept, you say it's -1 plus d, and it won't give you an estimate. So let's see. Right, there is no estimates of intercept here, but there was an intercept estimate with this guy, right? This is automatically including the intercept, but this guy will not include the intercept. Okay. And the second estimate is to say we use a double selection of the regression of the outcome on the treatment and the controls. So it's very simple. X is X, Y is Y, D is D, and we use double selection. We specify the method as double selection, and we run, and always use a summary to check the estimates. Summary. Sorry. Yeah, well, I have to library the package. Yes. Yeah. Now we get an estimate. So it's significant, but it's a positive effect, right? Remember, what is the treatment variable? It's the number of the strike down decisions on the eminent domain. So if the estimate is positive, that means it's gonna the struck down of the decisions. So is it reducing or increasing the price, house price? The number is going up. Yeah, it's increasing the house price, right? If the estimate is positive here, it will increase the house price. And this estimate says it's significant, but we are suspect because in this case, we don't know exactly if the treatment is exogenous, right? And we run the double machine learning to see the estimates. So basically quite similar, both significant and both positive. And then we gonna use our IV to get the false estimate. So we run the two-stage least square of Y on the treatment with only an intercept and only the first two columns of the V. There are two ways to do this. The first one is to say, oh, you only have intercept at the control, and you say X is the intercept, right? This guy will give you a vector of 1. So the intercept is a vector of 1. And you say X is this vector, and then you specify the intercept is false in this function. Another way to do is to say the X is empty, but the function will automatically include an intercept. So you say in the intercept is true, but you specify the X is empty set. So this guy will give you a null set. It means empty. And yeah, and you run this guy, and you get estimate. Let me see. Yeah, it's the same estimate, right? Both the estimates of the treatment is minus 0.1, the same, completely the same estimate, right? And how can we explain the estimate? It is significant in the two-stage least square with this low dimensional IV. Yes, the estimate is significant, and the sign of the estimate is positive. So that means the eminent domain will reduce, damage in the house price in this model. And then the estimate E is to use the double machine learning with IV. So we have ZI as an IV, but only an intercept as a control. Basically the same with X is an intercept, and D is D, Y is Y, V is Z. And do we have to select among the X? No, we don't have to, because the X is only an intercept. It's only one dimensional. So we don't have to select among the Z. The idea of the selection is to say if you have high dimensional, you have to select, right? If you have a high dimensional of X, then you say select X is 2. The default choice is 2 in this function. We run this and we get our estimate. It's not significant. It's not significant, but with a negative estimate, right? So this model says, although it's not significant, but it says the eminent domain will reduce or damage the house price. And the last estimate is to use the whole IV and the whole controls. And we say X is X, D is D, Y is Y, V is Z, and we select X. And we also select V to get our final estimate. It's definitely not significant. The p-value is quite large, and the estimate is positive. Do you have any questions related to the code, the coding?
Eu dei com muito. Eles não mediaram preço.
No?
Yes, let's do double machine learning automatically.
Only double machine learning. For the ID, only double machine learning, but you can always use double selection to estimate the model with ID, but you have to write down your own codes to implement this double selection. This function only supports the double machine learning. So we now can have a look at the summary of the estimates. Yeah. So for the OLS, not significant, but a positive estimate. For the double selection and double machine learning, for a significant and positive estimate with this IV, they say the estimate is not significant. Among the 1, 2, 3, among the 6 models, which one do you think is most credible? So basically, if in practice you have these data sets, what are you gonna do? You have many controls, you have many IVs. So the good try is to first include these many controls in the model, right? It will somehow mitigate the endogenous problem of the treatment. So the first step is to include many controls to see the estimate. And they say, oh, the estimate is significant. The eminent domain may have an effect on the house price. But the second try is, since you have many IVs, it's not safe to say, I've already included many controls. it's not safe to say the treatment is already exogenous, right? Because I mean, you say it's many, but it's limited, right? You can't include the infinity controls in the model. And the Sigma tries to, oh, we have a good IV, we think it's a good IV, and we include the IV to see what happened. And then we run these 3 models with IV. And the most credible one, I think, is the last model. So you include as many controls as you can, and also you include as many IVs as you can, then you get your estimate. The last one, I think, I mean, in my opinion, I think it's the most credible, but it says the effect is not significant. So the eminent domain does not have a significant effect on the house price. Yeah. It somehow, I don't know, do you think it somehow like follow the common sense in practice? I mean, the eminent domain does not affect the house price of the specific state. Do you think it's following a common sense?
Well, I expect that the prices would be lower because
Yeah.
because of the risk of expropriation by the
Yeah, I mean, it all depends on the amount of the eminent domain.
yeah.
I mean, you have a big state eminent domain, maybe some specific places for public use,
Yeah.
right?
But when it comes to like housing, if they're like a big residential area, then the possibility of having to move, I expect the price to be lower. But of course,
Yeah, I mean,
this is also another context.
yeah, I mean, basically in research, it's like a storytelling. I mean, yeah, as long as you can make your story like you can convince people, it's a good story. I, I don't care if it affects or not. For me, I don't care. I only care about how to tell the story to the audience, the people. I mean, if the people can buy my story. So, okay. So the idea is to say, why the last model, the last estimate is the most credible because we use many controls and we use many IVs. It seems to me that the endogenous problem is mostly solved among these models. Okay. Yeah. Any questions? Oh, you asked. Oh, this guy. Or the code. You mean this one? No, we don't have to use. No, with intercept, no minus. Without intercept, plus minus. Okay. Now you can do the second exercise. The second one, basically is house price prediction, but it's not a causal problem. It's kind of like a prediction problem.
Okay, right. Yeah, maar waar ik het de definition. Yeah. Ja, en dan wordt de kwestie van is het goed om uw boomlijn berecht? Zeker. Dus eigenlijk niet is. Nee, zeker niet. Hoe je dat niet doen is. Nee, dat is wel zwaar eigenlijk. Zwaar. Dat was niet meer waar. Ik wil checken Oliver. Dat ook doen. Zo alleen de puntjes. Ja, het is puur esthetisch. They practice it. Iets leuker dan een kind, dan dat gebeurt als je het wel bent. Die best die doen de tijd. Best wel even. Kun je ook een keer dat to end the best is of the Western decide on specific surgery. That's the region because the best symptoms, for example, from the bacteria.
And you have to install these three packages.
Yeah,
And library, the three package,
and
yeah,
Dave,
and follow the
dan
instruction.
stopt dit
Yeah.
erop. Maar aangezien dat maar is weer een... Is er een difference in how you animation thing that you just...
If you say false, you can run the code to see. Yes, you say select me is false. Yeah.
Yeah, then it's like, it's the only difference with all these combinations of animation, principles is only in this, when I select C and select
Yes.
it's only the after.
Yeah. If you run this, I think it will be return with some error.
Yeah, but I have cleared everything, so
Yeah.
if it worked,
You don't know how to get it.
yeah. Yeah.
Yeah, then you will I think you will get an error, right? In this case, so this is high dimensional. If you do not select on one of the three, so in OS, you cannot estimate the inverse of the x transpose x, right? If the matrix is the number of the covariates, it's larger than the sample size, you don't have the inverse. It's same case for the
Work,
yeah.
Yeah.
That's why you select.
Okay.
And this function is different. I mean, if you say select x is false, select d is false, this function doesn't equal to the two-state exists, right? Because it's a dumb machine learning. Yeah.
It's just a regular.
No, it's not a select. I don't know if because just if you don't use last, I don't know if you have cross validation in that case. And I think normally if you don't select, that means if you don't use the last, I think it's supposed to be recognize it.
Okay. And you like read soldiers in post?
No.
No, actually, because I try to
the default.
and it's make sure the stays different. Oh, it's a function. It's on the post lesson after.
Oh, personal.
It's post lesson,
Okay.
but
So
at the end, not in the beginning.
Okay, I see. So I mean, for the double machine, and you need to use lasso or post lasso. It will give you different activity, but that seems to be the two as other thing. So in the slide, you can see use lasso in the first step or post lasso.
But I don't think it's on the professor. It's Erla, so it should go to the those. That's HTML. Because it's true on default, which
I think in that case, you use post lasso to in the double selection instead of lasso. I mean, even if you treat this muscle, you know, now, this muscle, I mean, taking muscles, run, run, the additional or testing the selected tanks. Okay.
Yeah.
Basically, I think toxically they are the same. Okay. But if you the chapter 3, chapter 4. You see, you see lots of those things. Okay. That's how we can.
You create rules. You step clean. It's not the children. With that, mostly, it's really like the which is online. The zijn de mensen die package gemaakt hebben. Wow. Die wel nog niet eens. Ik vind het te bewarrend. Misschien dat je niet helemaal waarom wij niet loslassen kunnen. Waarom dat geen probleem meer is. Is dat omdat je geen. Nee, ja, want dat is niet, hè. Dat is als je maar denkt dat dat is omdat je gewoon van twice kostlossen leert. Dat is mooi. Gewoon niet boven. Degene die eruit gekozen zijn, met een positieve coëfficiënt, dan doe je daar OLS op. En die OLS, wacht, ik snap het. Ik denk dat je dan je relevante x'en eruit haalt en dan je residual via OLS maakt. Oké, dat zal waarschijnlijk niet dan. Ja, ik denk dat dat het hele punt is. Ja, dat is gewoon de variatie. Zonder dat er daar iets causaal moet zijn. Oké. Mooi compliment is. Ja, het ziet er inderdaad wel schoon uit. Ja, het is vervelend, hè. Dat eentje, kijk hoeveel krijg ik ben ook niet te was van de het is moeilijk. Oh, so he's poor. Ja, zo. Ik weet relate dat het er wel goed vind ik persoonlijk. Right now. Maar ik vind ook zoiets anders dan op de bed opstaan. Maar het is wel iets om te zien, zeker. Omdat dat het daar dat en wij willen niet tegen de zoiets. In de first place, van worden ze ook met de oorlog. Zolang er deze. Nu zeg je dat het klopt. Natuurlijk, 2 voor 30, ja, 10 euro is dan. Oh, new package. So Lewis. Ah, forest. Zo leuk met soms goed met een andere persoon. Ja, ik doe niet denken. En dan forest. En zo dus niet. Maar zo moet ik dat niet zeggen hoor. Want nee, depend on the version of car and the version of that is simply special case of your forest within what it is, one of those custom it's not one forest one it's dan moet je kan niet proberen. Ja, dat is juist heel veel als je maar meerdere bomen of gewoon moet rust. Je maakt meerdere bomen door dat je niet zelf ja, voetstuk is. En dan werken. Ja, ja, om ervoor te zorgen dat niet is constant dezelfde. Ja, dat was wel niet voor de rest. Ja, cool. Ja, dat is waar. Als ik dat lezen, ben ik altijd bang. Oh, dit gaat geen bezig. De twee woorden bootstrap en basement. De extra kost. En als ik dat lees, dan weet ik dat het gedaan is. Ja, het is eigenlijk, ik weet niet wat dat betekent. Ja, grappig, dat is zo in sociologie al, er doen heel veel tekstanalyse. En daarin wordt een basic statistics gebruikt, maar staan in de klikken van hoe die hebben rekening. Entry, or that was lecture. Dat is in het probeer. Dan wordt het capable. Ja, dat is helemaal lekker op natuurlijk. Uiteraard. Dat kan wel zijn, ja. Het van alles checken van de authentisch weer. Dit wordt iets ook met het business. Ja. Ah, ja, dat is niet goed. Dat is ook dat thema. Ik moet kijken naar hoe belangrijk dat altijd voor jongeren is. Oeh, dat is mooi. 500 miljoen. Wauw. Ja. Met 72 miljoen liters. Ja, het is random natuurlijk. Ah ja, maar we hebben de sessies. Ja, sessie. Maar je zit in de package staat dat wat natuurlijk kan wel een versie van het en ook een versie van de package. Dus op het moment dat ik nog weer 11.3 picture een beeld daar. Wel dus niet. Dat is nog heel chemisch. Bij with the fortune. Zeker. Of, sorry hoor, daar werk ik wel akkoord zijn. Het is gewoon even met de gelijke partners en bijna heel niet. Ja, ja, dat is maar voor de maaltijden bij de anderen, daar heb je wel ook wel klaar. Het is zo'n hele hè, maar het is wel gewoon betalen. Ja, het is alleen betaalbaar. Zeker voor de vrienden. Ja, ja, ja. Al dat gelach, hè. De laatste en zullen de eerste zijn. Het is vandaag witte donderdag. Jezus heeft het gezegd. Het is vandaag wasabi. Echt? Of think your margins too large. Dat had ik. Nice. Waarom heb ik? Ja, ook zo'n projectie. Maar je wilt hij dus. Ja. Dit kan van dan zie je voor het kaartje. Die hebben die ordens. Maar zo iemand. Ik kan er niet lang op nadenken over wat dat is. Oh, zo kun je en hier hebben we zo hard hebben met bestaan. Ja. Ja, maar wat? Ah ja. Mooi. En voelde bij anderen. Die nog goed. Waarschijnlijk is er niet een moment zeggen. Voor je ons. Ja, maar ja, dat is belangrijk, hè, voor sommige kanten. Ik heb niet meer wonen dan mijn kind. Ah, wel, ik heb minder wonen. Ik heb al een 500 wonen. Dus dan maar weer wonen. Maar ja, 25 wonen. En nog steeds. Zie je myself was die wil je niet zeggen. Growing is correct. Ja, cheese friends. Spannend. Oh, goed. En dan when you expect it, dat je te veel wat doen. Is het? Oh ja, we doen het beter. Doen het. 21. Dus, Oké, kijk naar de zoiets. Oh, nee, 19? Ik weet het iets meer van 19. Wat vind ik gedacht? Dat is nog 21. Snel eerlijk, hè? Oh, 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 oh. Wat? Ah, oh. Quindi, just ja, maar één links kan wel ook beter nemen. Maar dus het open en wat is dat? Nou, joh, hij kan was niet. Ja, maar je zal wel deze. Drie punten. Hier ook doen. Die is niet sterker. Ja, die zal dat het team dan. Dat zijn bij gewoon. Porties ook. Zit zo in zich. Zie je niet. Waarom? Waar in. Ja, zijn gewoon te zo lang. En hetzelfde, daar moet je voorstellen. Ja, tot hetzelfde. Ah, nee, helemaal niet. Waarom is dat van nu tot 35 en van mij tot 6? Ja, ik weet het toch niet zo. Maar dat is eigenlijk. Ja, bij mij is skateboard. Is dat niet die forest? Ja, dat is een bos. Was het? Ik heb mijn bomen beperkt. Dus moet je ik heb maar 29 bomen. Ja, dat is niet wel. Dat is zwaar. Niet goed. Ah ja, dit ziet er al op. Lijntje doen. Goed. Ja, lijntje. Prachtig. Ah, dat wil eerst. Ja, zo kan het goed. Zo kan het best wel. Al is het niet wel. Echt niet goed. Het is een beste pepper. Ja, dat wil je. Ach, nog graag. Yes. Maar je barriet. Waarin posters die zijn worden in plannen van shops. En dat is dat. En dat is wel. Ja, oké. Ja, en dat is voor die snip. En heb even mis mee. Hoe lang maar 17 minuten werken. Heb je ook nog? Is er niet? Ja, en je komt ook niet zeggen. Percentage. Het staan die file, hoe dat is het precies van mij dat moet echt. Dus nee. Nee. Maar het is wel mijn nieuwsbrief te maken. Would decrease the accuracy and predictions of all bad samples.
Shall we have a look at the second exercise together? So the problem is predicting the house price. But normally the trees or random forests, I mean, normally they are used for classification problem, but they can also be applied to regression problem. So the outcome is continuous or binary, right? In this exercise, it's a continuous outcome, right? It's a house price, right? But normally the random forest or tree are used for classification problem, right? Yeah. So what I want to say is, I mean, yeah, the tree can be used for both classification and continuous outcome problem. So we library the packages we need, and we have a look at the data, the Boston data. Where is the Boston data? Yeah, the Boston data. So we have several covariates, and the last column is the medium of the some house price index, I believe. So you can always help the dataset to check what's the definition of each covariate. So the crime, I mean, the average number of rooms, age, somehow, and the outcome is the median value of the houses, I mean, in these units. So what we want to do is to use the tree or the random forest to get a better prediction of these house price. So let's say in practice, you want to evaluate the prediction accuracy of your methods. That you have a whole data set. What you're gonna do is to split the data set into two folds, right? One fold for the training you use one fold to estimate your parameters, and you use another fold which is called the test set to evaluate whether your method can get a good prediction accuracy. So yeah. Oh, I see. Yeah, great. So we first randomly split the dataset into the train and test fold. So by using this command, and we randomly sample half of the sample size. So there are how many? 506 observations, and we use half of them at the training set. So the length is half of 500. Yeah. And the first is to build a decision tree for the prediction, and it's very simple. We specify what is outcome, so the outcome is called this guy, and we use all the covariates. So this command means you use all the covariates. Okay, and the data set is from the Boston, and the subset, that is to say, you only select these indexes in the whole sample. So you only select, for example, like the first row or the second row at the training set. Is it clear? Okay. And then we can get a result. So we mainly focus on the residual mean. This guy, so it's not bad. It's a single decision tree, and we can see how it splits these covariates. It is like that. So let's say if we focus on a one node here, so it's if this covariate is smaller than a critical value, we go this way. If larger than this value, we go the opposite way. And the second one is to say, let's see, let's say. And the second one is the use of this cross-validation of the trees is to say if whether proving the tree can improve the performance. So we can first use the cross-validation to see how much we have to prove on the tree. So normally by using this command with cv.tree, this is a single decision tree, and we try to cut some terminal nodes to see if it can improve the prediction performance. Oh, why is it a bit different from you guys? Oh, I see. Because you have to set a seed, because when you use the cross validation, it's kind of like some random split in the data set. Okay, let me run it again. I have to set a seed first to replicate the result. Then I get a same result as yours, I suppose. Right? If you set a different seed, let's see what happens. Oh, doesn't change a lot. Still. Yeah. Minus change, right? Yeah. So in this case, we can see maybe the best one is so the best size of the tree is 7 or maybe 6. Then we can run a single prune procedure to see the result. So we prune the decision tree. So the tree Boston is the decision tree, and we prune the tree by select. This is what you have to specify. The best equals 7. What does it mean? If I say best is 7, then I prune the tree. Do you notice something which equals to 7 in this plot? In that case, the 7 means the number of the terminal nodes. So what are the terminal nodes? So this is terminal nodes. 1, right? 2, 3, 4, 5, 6, 7, right? 7 terminal nodes. If I say I want to cut the tree with 5 terminal nodes, how many are there? 1, 2, 3, 4, 5, right? If I say 15, sorry. Oh no. Best is bigger than the tree size. I think it doesn't work. Maybe we try 8. 1, 2, 3, 4, 5, 6, 7. I think the best is 7. Okay. 7, if you run smaller than 7, 3. Yes, 3. The best one is 7 in that case. Okay. And this is only on the training set, and we want to evaluate the prediction accuracy. So we have to use the estimates from the decision tree to predict the house price in this test set. And we put input, the first argument is your decision tree, and the second argument is your new data set, which is your test set. So the minus trend is to say you select the rest of the index in the train. Is that clear to everyone? So I can show you a simple example. Let's say A is Boston. So I only select the first rows of the data, and I say train index I only want to use 1, 3, 6 at the train index. So if I run train index, and when it gives you, oh sorry, oh the train index, sorry. You see it only gives you the first row, the third row, and the sixth row, right? If you run the minus, it will give you the left rows. 2, 4, 5, 7. Is it clear? Okay. Great. Then we can calculate the mean, the square root error between your estimate and the true price, in your test set. So this guy is, the common evaluation metric for the prediction accuracy. Is this clear to everyone? Okay. Yeah. Then we can move on to the bagging and the random forest. For the random forest, we have to library this package, the same data sets, the same outcome, but here we, instead of using a decision tree, we want to use a random forest. So the formula of your regression, the data, what is the training set, and this guy means what, mtry means what. Remember the difference between bagging and the random forest. The only difference is when you split it in building the tree, when you split a node, if you look at the whole number of the covariates, it's bagging. If you only select, let's say, maybe 5 of the whole covariates, it's called random forest. Here in the data set, we have 13 covariates, right? We have 13 covariates. So this one, we use the whole number of the covariates. So this guy will return you the bagging. Okay, we get a bagging, and we can get the prediction result. So it's much smaller than the single decision tree, right? And then we can try the random forest. So yeah. And also another argument is you can also specify the number of the trees in your bagging. So the default number in this guy, the default number is 500. You can decrease a bit. You can say it's 27 to see if it affects the prediction error. So you can see it barely change, right? So that means you don't need that many trees to get a decent prediction. And then you can run the random forest. So you say, for each split, I only select 6 out of 13 covariates in each split. So it's a random forest. And then we can see, by using the random forest, we can see the increase of the prediction performance, right? Is this clear? The argument mtry and this guy mtry and the number of trees. Is it clear to everyone? Okay. It's less important than the double selection or double machine learning in the final exam. Okay. For the trees, I think the main goal of the trees is for the non-parametric model. In the next chapter, we have to estimate the non-parametric model, the function g, right? Then we can use the random forest to estimate the function g. And I think that it's the main use of this random forest, but not singly using this random forest for the prediction. Okay. And then we can check some importance of the covariates. So the first one is the it's kind of like global importance. So let's say if we don't have these covariates, does it damage the prediction performance? So the larger the guy, the larger this value, it means the more important these covariates. And another is called, the node purity. It's a bit hard to explain. It's like in each split is this covariate. Does this covariate matter a lot? So this guy measures the covariance for the global performance to, let's say, if it can increase the prediction accuracy. And this, the second guy is to say each split, does it matter? Okay? Is everything clear to everyone? Great. Yeah. I think, yeah, it's, I think we can conclude here. The takeaway, I think the main takeaway today is for the exercise 1. And you have to, I mean, after this lab session, you have to ask yourself, why with exercise 1, why the judge decision is endogenous in this problem? And if you have such data set in practice, how can you mitigate the endogeneity issue? When you're building a model, when we have many controls, we have many IVs, how to estimate in that case? The main takeaway is exercise 1. And yeah, I think it's all. Any question? No? Great. Wish you have a great break. Okay. See you after 2 weeks, I think. Yeah.